Hello guys, welcome to the DMS online school. In today's video we are going to revise a topic which comes from science paper 2, which is known as separation technique. So in this video, in this revision I've put all the questions from separation techniques that have ever come from 2009 to 2024. I've put them together in this revision so that you will be able to understand how questions are brought on separation technique, with the view that as you go in the exam, if there will be a question that will come on separation technique, it will look like the ones that I'm going to revise in this revision. All right, so without further ado guys, let's go straight into this revision. So this is a question 3 which came from a certain paper in a certain year. So the question reads: paper chromatograph was used to catch a forger. A sample of ink X from a forged signature was compared with inks from the pens of 5 suspects. The diagram below shows the chromatogram obtained. Okay, so from here what we are able to see is that there was actually ink X that came from a forged signature, and also there were other 5 inks that came from suspects. So both or all of them were compared on paper chromatograph, and the result came out as shown. So when the ink from the suspect, which is X, and ink from pen A, pen B, pen C, pen D, pen E were placed on the paper chromatograph, then they separated after paper chromatograph into these components we are able to see. So this separation of these components is what we call chromatogram. Okay, so now X is separated into 2 components. A did not separate into N, B separated into 3 components, C separated into 2 components, then D separated into 2 components, then D equals separated into 2 components. Okay, now the whole point of doing this was to catch a forger. Okay, so this was the ink from the suspect pen, then these are the suspected people. So the ones whose pen is going to have the same ink like the one in X will be the pen that was used. So like here, if we check here, none is like this. Here there are 1 2 3, here there are 2, just here there are 1 2, but this has nothing to correspond with this. But when we come to D, D has this which is similar to this, and then it has this which is similar to this. So you see the components from X have moved the same distance from the starting line as the components in D have moved. So it means that ink X and ink D are one and the same thing. Okay, so this is how actually paper chromatography works when it is used to catch criminals. Okay, so now let's proceed to the questions. So question A says, draw the apparatus you would use to produce this chromatogram. Okay, the apparatus that would be used to produce this chromatogram would be in a laboratory, a beaker like that filled with either water or ethanol. In this case I said ethanol, and inside it you can dip a filter paper like that, and then on the filter paper you can draw a line using a pencil which we call pencil line, and then you can draw another line which we call solvent front, which is the point at which the solvent reaches from the start or pencil line. So basically this is the apparatus that was used to produce these results which are here. Okay, then let us continue to answer the other questions. B says, which of the inks A, B, C, or D, A, B, C, D, or E could have been used to write the forged signature. So here I told you that it was going to be D because D had the same components as those in X. All right. So here D. Then C says which of the inks is insoluble in water. So of these inks here, A, B, C, D, E. Which one is insoluble in water? Okay, the one which is not soluble in water, or the one which is insoluble in water, is actually one which did not produce any spot. Like A did not produce any spots. This could be that either the spots, if it did produce, they are actually colorless, or if it did not produce any, meaning that A is actually insoluble. So in this case, that will be our answer. Which of the inks is insoluble in water? A. Then question 2 says the diagrams below show 4 different methods of separation. Okay, so we have these 4 diagrams here that show different methods of separation. So we have separation method A, separation method B, separation method C, separation method D. Then A, they're saying using the letters A, B, C, or D, identify the methods used to Roman numeral 1, separate insoluble particles from water. Okay, an example of insoluble particle are sand. If you put sand in water and you are asked to separate sand from water, of these methods here, which one can be used? Actually, it is C, which is the filtration. So here the answer can be C, which is the filtration, where you can pour a mixture of sand and water on the filter here so that the sand can be trapped here and water can come out here. Okay. Then Roman numeral 2 says separate a mixture of different dyes. So what can be used to separate a mixture of different dye is separation method B, which is the chromatography. Chromatography is the one that is used to separate different substances of different or colored substances. So the answer is B. Roman numeral 3 says make crystals of copper 2 sulfate from copper 2 sulfate solution. So of these 4 methods here, the best one is D, which involves heating the solution to evaporate any liquid so that the crystals can remain on the separating dish here. So the method is actually D. We come to Roman numeral 4, separate water and cooking oil. So water and cooking oil can be separated using separating funnel, which is separation method A here. So here our answer is A. Then B, state one industrial application of chromatography. So chromatography can be used to determine purity of substances, or can be used to determine composition of substances, or can be used to identify counterfeit substances, or it can also be used to catch forgers. All right, so let's move to the next question. Question 1, which came from a different paper in another year, which reads the diagram below shows a method by which a mixture of sodium chloride and iodine crystals can be separated. Okay, we have a mixture of sodium chloride and iodine crystals can be separated. So this is the method. What we can see here is that we have this apparatus here, inside of which we have a mixture of sodium chloride and iodine crystals, and then we have on top of it an inverted funnel and solid B, which is being formed. Then A says give the name of the separation technique shown in the diagram above. So this whole separation technique shown here, what name is given to it? So this is actually sublimation. Then B, they're saying name apparatus A. So this apparatus A here, what do we call it? We call it separating or evaporating dish. Then identify solid B. This solid B here could be iodine crystals. Why? Because when you have a mixture of sodium chloride and iodine crystals crystals undergo sublimation, and therefore if they are heated they'll evaporate and change into solid and form solid here. So solid B would be iodine crystals. Then D, they're saying explain why sodium chloride solution is regarded as a mixture. So you can say that because it can be separated by physical methods such as crystallization, or you can say that because it is made up of water and the sodium chloride. All right, then we can move to question 22, which came from a different paper in another year, which says the diagram below shows an arrangement of apparatus used to separate a mixture of methanol boiling point 15 degrees Celsius and water boiling point 100 degrees Celsius. Okay, so this is an arrangement of an apparatus that is used to separate a mixture of what? Methanol boiling point 15 degrees Celsius and water boiling point 100 degrees Celsius. They're saying which part of the apparatus is wrongly arranged and what is likely to be liquid J when collected or corrected. Okay, so when we look at this, we need to observe this apparatus altogether. So here we have a mixture of methanol and water being heated, which means that since methanol boils at 15 degrees Celsius and water at 100 degrees Celsius, methanol will be the first one to boil off because its boiling point is lower, so it will be collected here. When they say liquid, actually J, it should be methanol here. Then correction. What correction can be done to this? Something which is wrong that we need to correct. So it could be water because water should enter from the bottom and come out from the top. So here, cold water should enter from the bottom and leave through the top. Yeah, so the answer is B. Then we move to question 2, which came from another paper in a different year, which says which of the following apparatus can be used for separating immiscible liquids. So immiscible liquids are liquids like cooking oil and water. These two do not mix uniformly when you put them together, and an apparatus that we use to separate them is actually separating funnel, which is actually B. Then 3 says, what is the volume of the liquid in the measuring cylinder below? So the level of the liquid is here. So what is this volume here? So when you check here, we have 20, but we do not have lines here so that we can know. Common sense in science tells us that this line here is the same as this line here. So here I can't see the lines properly, so therefore I can use this demarcation here. So if this is 30, I can say 32, 34, 36, 38, 40. Therefore I can say if this is 20, this is actually 28. So the answer is D here, 28 here. We move to the next question. 8.2 says the diagram below shows the experimental setup for the determination of the boiling point of a liquid. Okay, so they were determining the boiling point of a liquid: thermometer, capillary tube, round bottomed flask liquid, then porcelain chips. Then they're saying which statement explains the purpose of adding porcelain chips. Why did they add porcelain chips in the liquid? As they were heating it to determine its boiling point. So A, to ensure smooth boiling of the liquid. Yes, so the answer is A. Then we come to question A3, which says the diagram below shows a chromatogram for various types of ink. Okay, we have ink. Black has got one color or one spot, blue has 3 spots, brown 2 spots, green 1 spot, red 2 spots, and yellow has 2 spots. Okay, so then they say which statement is correct about the chromatogram? They are saying A, red ink contains black ink. Okay, so let's see. Red is here and black is here. Black has this ink here. Let's see if we have an ink per red which is at the same level as this one per black. No. So this is wrong. Then we go to green. Green ink contains red ink. We come to green. Green is here, and then we come to red is here. Now, when we check at green, we don't have a color here, and green has only one spot and red has two. So there is no way that green can contain red, when in fact there are no colors that have moved the same distance here. So that is wrong. Then you see black ink and green ink are pure inks. Okay, so black has separated into one spot, meaning it is pure, correct, because a pure substance separates into one spot. That's why when they said that question, we answered it to say you name one application of chromatograph. I said to identify the components of a mixture or to determine the purity of substances. So if a substance has one spot, it has separated into one spot, it means it is pure. Like black is pure because it has one spot, while blue is not because it has other mixtures in it. So green has one spot and black has one spot. These are pure. So this, see, when it says black ink and green ink are pure inks, that makes sense. So that is the answer. Here they are saying blue ink can be made by mixing brown and green. Blue can be made by mixing brown and green. No, that's not true. If you get this, you mix, you only form this. You will not be able to form this other one. So the correct answer is C. We move to A3, which says identify a mixture of substances that can be separated using the apparatus below. So this is a separating funnel which is used to separate immiscible liquids like water and cooking oil, water and paraffin. So when they say a mixture of A, is the answer paraffin and water. Why? Because these are immiscible liquids. When you mix water and paraffin, they will not mix, so you can separate them using this method. Okay, then we go to A2, which says identify the measuring apparatus shown in the diagram below. So this measuring apparatus, guys, is known as a volumetric flask. So the answer is actually the volumetric flask. All right, then we come to B2, which says the diagram below shows one of the laboratory apparatus. So this is one of the laboratory apparatus. A says name the apparatus. So this apparatus, guys, is a separating funnel. B, Roman numeral 1 says state the use of the apparatus shown above. Actually, separating immiscible liquids. Then Roman numeral 2 says suggest two substances that can be separated by the apparatus shown above when combined. It's actually water and cooking oil, or paraffin and water. Guys, if you're enjoying this video, give it a like and let me know also in the comment section. For those that have not subscribed, please consider subscribing to the channel by clicking on the red subscribe button below, so that when I upload new videos like this one, YouTube will be able to notify you. All right, so let's continue. So we'll come to A2, which says the best apparatus that is used to accurately measure a required fixed volume of a reagent during titration is, let's read again, the best apparatus that is used to accurately measure a required fixed volume of a reagent during titration is. So the key point here, or the key word, is accurately, then fixed volume. So which apparatus measures accurately fixed volume? Is actually this B here, which is actually a burette. So the answer is B here, which measures exactly 25 cubic centimeters up to the mark here. All right, then A3 says the best method to separate a mixture of sand and diesel is. So if you want to separate a mixture of sand and diesel, can we use decantation? Yes, it can. Distillation, no. Evaporation, not really. So the best method is D, which is filtration. Okay. Then we come to B2, says a learner carried out a chromatograph experiment to identify components of substance X. Water was used as a solvent. The results of the experiment are shown in the chromatogram below. Okay, so the learner carried out this chromatograph to identify the components of X. Okay, then what happened, had also to get these components of non-A, B, and C, and non-components were also put there. And X separated into that, A did not separate, B separated into that, C separated into that. Then the solvent, which is a starting line here, moved the distance from here, the solvent, to the solvent front there, the distance of 28 cubic centimeters. Then A, they are saying which one of the unknown components A, B, or C is insoluble. Okay, the one which did not separate into other components like A can be known to be insoluble. So A, explain your answer. We can say did not form a spot on the filter paper. Yeah, so A did not form a spot on the filter paper, therefore it is insoluble. Then B, which of the unknown components was or were not contained in substance X? So the one which was not contained, like X had this separation, distance from here to there is the same as the one for B. So B was a component of X, but A and C, since A did not form any separation spot, meaning that A was not part of X, and C made this one, which is not on the same level as this. So meaning that C was not part of X. So in this case, when they say which of the unknown components was or were not contained in substance X, we can say either A and C. Then we move to C, where they are saying calculate the RF value for component B. So the RF value, so let me just get back to here, because where we are now, we are here. Okay, so now they are saying we calculate the RF value for component B. RF value is the ratio of the distance moved by the solvent to the distance moved by the ratio of the distance. So RF retardation factor. RF is the retardation factor, which is the ratio of distance moved by solute, in this case B, over distance moved by solvent. So in this case, we can say the distance moved by the solute is from here up to there. So the distance move, which is from here up to there, how can we know it? We can know it if we say 28 minus this. You see how science behave. They will not tell you the distance here, but they will say, if you know from here, can you fail to know from here up to this level? You can, where you say 28 minus 27, you get 21. So this distance here is 21. So that you say the distance moved we are here actually, so that you say the distance moved by solute, which is equal to 21 centimeters, over distance moved by solvent, which was 28. These centimeters will cancel. 21 divided by 28, you get 0.75. So therefore, this is the RF value. Then you come to A2, which says the diagram below shows one of the methods used to separate mixtures. Okay, so we are seeing a beaker containing some mixture residue remaining here. One of it is coming out. The beaker clear solvent. The above method is what? So the method which we use to do this is decantation, which is C. We come to A4, which says a mixture of salt and iodine crystals was heated for 20 minutes as shown in the diagram below. So there is a mixture of iodine crystals and some salt here heated for 20 minutes, and we are seeing something separating there, R, and something remaining there. What is R and S? So R actually there, if we have iodine crystals, that will be crystal. So R will be actually a sublimate. So it will be sublimate. Then SC, which will remain here, it is a residue. So the answer is B. We move to A B2, which says the diagram below represents a paper chromatograph of 3 sugars K, M, and N. So this is a paper chromatogram of 3 sugars, which is M, K, and N. Okay, so M separated into this dot, K into this dot, N into that. Then A, they are saying state the most soluble sugar. The most soluble sugar is the one that moves the furthest distance, like N. Okay, the furthest distance from the starting line. Then B, on the chromatogram above indicate the solvent front. So here we indicate this is the solvent front. There was no need also for them to draw the spacing here because the answer needed to be drawn here. Okay, then we come to Roman numeral or to C, which says the 3 sugars K, M, and N are colorless. What should be done to make what should be done to the chromatogram to make them visible? You use a locating agent. So a locating agent must be used. Then D, they are saying explain how chromatograph can be used to identify false banknotes or forged paper money. We can say that a sample of ink from the suspect is separated into its components on chromatograph paper using a solvent. The resulting chromatogram is then compared to that of a genuine banknote. Differences in the patterns indicate that the ink may be counterfeit, as real banknotes have a unique ink composition. We move to B2, which says the following is a list of methods used to separate mixtures: filtration, chromatography, crystallization, distillation, fractional distillation, evaporation. Choose from the list above the suitable method that would be used to obtain pure water from sodium chloride. If you want to obtain pure water from sodium chloride, you can use distillation. Then B, separate a mixture of ethanol and water. If you want to separate a mixture of ethanol and water, you use fractional distillation. C, obtain copper 2 sulfate crystals from saturated copper 2 sulfate solution. You use actually crystallization. D, obtain barium sulfate from a mixture of barium sulfate and sodium nitrate. Here you actually use filtration because barium sulfate is insoluble, yet sodium nitrate is soluble, so you use filtration. Then E, separate colored substances in a sample of soft drink. You use chromatography. Okay, then A2, we say a learner accidentally mixed ammonium chloride and common salt. What method would you use to separate the mixture? Sublimation. A3, the results of a paper chromatography experiment are shown in the diagram, in the chromatogram below. Okay, let's come here. So X is an aqueous solution of a sort of group one element, then Y is an aqueous solution of a sort of a transition metal. Okay, so they had to put X, which is a sort of group one element separated into that. Then they had to put Y, which is a sort of a transition element which separated into that. Then they're saying which row is correct? A, RF value, large RF value. The one which will have a large RF value is Y. RF value, the one indicated distance moved by the solvent, solute over distance moved by the solvent. So this one will have a big RF value. So either this one or this one. Then it requires a locating agent. The one that will require a locating agent is the one which forms a colorless salt. In this case, the one which forms a colorless salt is X because sorts of group 1 elements are colorless. So the requires a locating agent will be actually X. So the answer is A. Then we come to B2. Figure B2.1 shows a separating mixture used to separate immiscible liquids. Okay, so this one is fractional distillation. Then they're saying, what is the name of this apparatus? That is fractional distillation. What is the purpose of the glass beads in the fractionating column? So the purpose of these glass beads in the fractionating column. What is the purpose of the glass beads in the fractionating column? We say to condense volatile fractions. Then they're saying, see, why is the Liebig condenser kept in the slanting position as shown in figure B2.1, like this one here? Okay, so let's see, where are we? Why is this one in the slanting position like that? That is the question that we are asked. Okay, why is it in the slanting position like that? So we can say that to prevent backflow of fractions. Then D, apart from the mixture of miscible liquids, name 2 other mixtures which can be separated using this method or using this separation technique. We can say crude oil or air. Okay. Then we come to A3, which says, which of the following shows the best order of obtaining salt from a mixture of sand and salt? So we have salt. So the answer is A, dissolve, filter, and evaporate. Then F4, they're saying the best method of separating iron filings from copper powder is actually magnetism. All right. Then F5 says the following diagram shows a chromatogram obtained when sample V was analyzed together with 4 other known dyes W, X, Y, Z. Dye X was known to be poisonous. Okay, so we have V, W, X, Y, Z. Then they're saying X is already poisonous, this guy here, which separated into that. Then they're saying which of the following dyes are safe for use? Okay, X, since X separated to this, so even this component and this, they're the same like X. So since X is poisonous, it means this all together are poisonous because they have this and this and this, the one and the same. So the one which is safe is Z. So the answer is Z only. Then A3 says, which of the following species of apparatus can be used to measure accurately a fixed volume of a liquid? Again, fixed volume of a liquid. Accurately, fixed volume of a liquid, it is actually pipette. Then F4 says, identify a separation technique which can be used to separate a mixture of water and butanol, actually fractional distillation. Okay, then B3 says the experimental setup that follows shows a mixture of sand and iodine crystals in an evaporating dish here. So here we have a mixture of sand and the iodine crystals. Then A, describe how the mixture of sand and iodine crystals can appropriately be separated. So we can say, gently heat the mixture in the evaporating dish and cool it. Iodine crystals will sublimate and can be collected by cooling them back into solid form while the sand remains in the dish. B, explain why bottled mineral water is not pure. Okay, is not pure water. You say bottled mineral water is not pure water because it contains dissolved minerals and other compounds. Then C, give one criteria for purity of a substance. You can say a pure substance has a specific sharp melting point. Okay. Then A3 says it was suspected that a substance X was one of the 3 substances J, K, or L. Spots of each substance were put on the starting lines of 2 pieces of chromatography paper. One paper was developed with water and the other with ethanol. The final diagrams are shown. Okay, so we have this JKLX. This was developed with water. This they separated like that. Then we have diagram 2, JKLX. It developed like that. This was developed using ethanol. What is X? So when you see X was one of the three. So X was one of these three, JKL. So here, when they separated using water, the ones that had moved the same level as X were actually K and L. When they separated with ethanol, the one that had moved the same level as X was actually K and J. So here we see that K had the same level and here the same level. So it means that what is X? X is actually K. So we can say K only. Then we come to A4, which says which mixture of substances can be separated using a magnet? A, iron filings and sodium chloride. Yes. Then we come to A3, which says the following diagrams show volumetric apparatus. Which apparatus measures only approximate volumes of liquid? The one which can measure approximate should be this one here, measuring cylinder. It doesn't measure accurately but approximately. Okay, so guys, if you're enjoying this revision, give it a like. And for those interested in chemistry revision, there are videos already made, topic by topic revisions through past papers at 50 kwacha. You can contact me on WhatsApp number. Don't call. WhatsApp number 0977 92 41 75. 0977 92 41 75 for revision videos topic by topic like this one here. So this video focused on separation techniques. There are other videos that are focused on different topics. So if you want to revise those tonight, you can pay 50 kwacha, you'll be added to the group. Okay. Then A4 says which mixture can be separated into its components by adding water, stirring, and filtering? So the answer is A, iron and sodium chloride. Okay, then B2 says the following diagram shows a piece of apparatus used in the laboratory. They're saying A, name the piece of apparatus shown in the diagram. This is separating funnel. Then BS, they are saying B Roman numeral 1, they are saying identify one property of a mixture separated by the piece of apparatus named in A. They are immiscible and have different densities. Then Roman numeral 2 says suggest the names of two liquids that can be separated by the piece of apparatus shown in the diagram. It can be water and cooking oil, or water and the paraffin or petrol. Then then C says suggest two precautions that need to be taken to separate the mixture in B2. So you can say open the tap slowly to control the flow and prevent sudden release to avoid mixing. Okay, so we have come to the end of this revision. If you enjoyed it, give this video a like and let me know in the comment section. If you haven't subscribed, consider clicking the red subscribe button below and turn on the bell notification so that when I upload a new video like this one, YouTube will be able to notify you. So thank you very much for watching for now. Bye and see you in the next video. Peace.